You guys must like security a lot because there are 2 other sessions that are happening, and I thought nobody would show up. When Duck Cutting and Sanjay are talking, I expected nobody would be here in the room, but you guys must care about security. So thanks for coming here. My name is Vinay Shukla. I'm a Director of Product Management for Security at Hortonworks, and I like to think I'm a developer because of my 18 or 19 years of professional career. I've been writing code for 15 of them, and I go back and forth between programming and product management. I like to think I'm a better programmer, but people who have worked with me for 10, 15 years, they think I'm a better product manager. So let's talk about security in Hadoop and why it's important. So this is the agenda I'll walk you through. And the basic question is, why do we care about security? And why do we care about security in Hadoop? And the answers are very simple. The answer is Hadoop contains sensitive data. If you don't have any sensitive data in Hadoop, if you never put any sensitive data in Hadoop, you wouldn't care about security in Hadoop. And also, because Hadoop, as the data processing platform, is no different from other data processing platforms that you have in your enterprises, for example, a database. And they also have legal and compliance requirement. You have to all comply to your CSOs, and we can't escape that. So those requirements apply on Hadoop as well. And that's why it's important for us to be aware of security capabilities that exist in Hadoop, be aware of what is possible today, what's coming on the roadmap, and where we are going. So that's the gist of the talk. So what is security in Apache Hadoop? So this particular slide is applicable to most systems, most software systems. So security in Hadoop is defined by 4 key pillars: authentication, authorization, some people call it accounting, other people call it auditing, the 3rd pillar. The 4th pillar is called data protection. Some people call it encryption. So these are the 4 basic principles for security, or 4 basic elements of security that apply to Hadoop as well as to other systems. And in that case, Hadoop is no different. So another principle of, if you talk about security, there are few basic tenets of security, or basic principles of security. One of them is that defense in depth. So you don't want to have just one lock for the entire house. If you have something sensitive, you have another lock, and that's the basic defense in depth principle. So in Hadoop, and in any network system, the outermost layer is called perimeter security. And the perimeter security's job is to stop the bad guys farthest away from whatever you're trying to protect. So in this case, we are trying to protect the data. So the job of perimeter security is to stop the bad things from happening as far as possible away from your data. And perimeter security can be applied, can be thought of at 2 levels. One is at the network level with the firewalls and all. At the second level is what is called as API gateways. And we'll talk about Apache Knox and how it fills that role in more detail later. So the next level of defense is authentication. And basically, unless you have authentication, the rest of the security, for example, authorization or auditing, is meaningless because you need to know who the user is. And it's not just knowing simply who what the user claim is, but actually validating the user claim. So authentication is trying to figure out who the user is and validating their claim. So that's authentication. The specific way in which authentication is implemented in Hadoop is using the protocol called Kerberos. And Kerberos, the 3-headed dog, is the only way to have secure authentication in Hadoop. If you know security in Hadoop, you'll say that Kerberos is not enabled out of the box in Hadoop. The way authentication works out of the box in Hadoop is called simple authentication, which, despite the name, is not. It assumes trust in users' claim of who they are. It doesn't validate the trust. So that's not anything, the simple authentication is not anything that you would recommend for a production environment or you would use in a production environment. For that, you must have Kerberos enabled. The next layer of defense is authorization. So as you know, that Hadoop has a lot of different projects, a lot of different components. There is HDFS, there is MapReduce, there is HBase, Hive, Accumulo. The list keeps growing every day. I just heard somebody mention as I was walking out of another presentation the other day that the list of projects in Hadoop was mind-boggling last year. And now this year, it's like they don't even have words to describe. So why it matters to you is that if you are in charge of securing your entire Hadoop deployment, you have to understand authorization capability in the entire product or entire suite of components. So, for example, in MapReduce, the authorization is controlled through what is called access control list. So those of you who are familiar with the access control list, it's nothing but saying a given resource, and in MapReduce, the resource is the job queue. Who should be allowed access to that given resource? So if you, in that mapping, you say this MapReduce queue should be allowed access to this group, or you can say this user. And that's basically an access control list in a nutshell, and that's what MapReduce access control lists are. Then in HDFS, the security is based on the POSIX model of file permissions. So you can do shamad or define the file permissions or the directory permissions. And that's there in Hadoop today, or it's been there for a while. Starting the next version of HDP, and that will come out very soon, you will see there is something called HDFS Extended ACL, which is another enhancement to security in HDFS that our team at Hortonworks put together in this release. And what this capability will give you, with HDFS, you had what was possible that if you wanted to put a permission on a given directory, you defined it by the shamad number, 777, 750, whatever. But if you wanted to have multiple permissions on the same directory, it was not possible. You had your workarounds where you had to create different aliases in Unix groups and grant that to different groups. So you had to do some workarounds. Now with extended ACLs, you can have multiple permission models on a given directory. So you can say a group in finance department should only have read access to a given directory, but a group in marketing should have both write and read access. So that's what you'll get with extended ACL. Then in Hive, the current authorization model is based on storage-based authorization, which is essentially mimics the permission in HDFS. So it's at the file system granularity. It's not at the table or the column level. With Hive authorization next generation, which is going to come out in HTTP 2.1 release, and again, the timelines are very soon, you will get Hive authorization next generation. And what this will give you, a SQL-like semantic. So, for example, in a database world, the way you configure permissions on a table or a row or a view, it's grant on a given table to a user or a group or a role. And that's the same model we are bringing to Hive table. So with Hive authorization next generation, you'll be able to say grant or revoke on a given table to your users or groups. And that's what Hive authorization next generation is. And then HDFS, or HBase rather, had access control lists for a while, and Accumulo has label security. So that's the authorization ring. Then beyond that is OS level security. So OS level security is always there. You can use, for example, the volume-based encryption and things like that are configured at the OS level. And then you'll notice in the next one, a cross-cutting ring of security, which is called data protection or encryption. It applies to every aspect of security. And let's go into more details in each of these. And there is the baby elephant being protected. So let's talk about what's possible in authentication today. If you were to implement authentication, which is where the security starts, what choices do you have? What can you do today? So essentially, authentication is proving the user's claim of who they are, and so that you can decide whether they should be allowed access to a given resource or not. And the choice, as I mentioned, is Kerberos, and that's the only choice. But with HTTP 2.1, with Apache Knox, you're getting another choice, which is at the perimeter level. And if you imagine the outermost ring, you can, at that ring, Apache Knox will provide additional security options. And we'll go into more details when we talk about Apache Knox and to what those options are, and we'll see a demo. So let's talk about what is the first level of security, which is Kerberos. So Owen O'Malley and a bunch of other Horton workers were the first people who implemented Kerberos in Hadoop while they were at Yahoo. So Kerberos is a pretty standard protocol, and it's been there for 20 years or so. And unlike other authentication mechanism, Kerberos is called strong authentication. And the reason why it's called strong authentication is when you say go to your browser and put your username and password, and let's say you're using the basic authentication scheme, which nobody should be using now, but basic authentication gives you a pop-up in the browser, and the username and password is base64 encoded, sent over the wire to the server. The next better scheme is form-based authentication. In form-based authentication, the username and password is again sent over the wire. If you have SSL enabled on the website, then it's sent over the wire in an encrypted channel, but still the username and password are both sent over the wire. In Kerberos, the username is sent over the wire, but the password is never sent over the wire. So I'm not going to cover Kerberos in more detail. There are a lot of materials that talk about what is Kerberos and the protocol details. But Kerberos, the way it does is that it uses just like in private key and public key cryptography, possession of one implies the other one. So if you have public key, you can prove whether you're the only one. You can validate somebody's private key, that they have the private key. Using that technology, Hadoop or Kerberos never sends the password over the wire, but still does authentication. And that's why it's called strong authentication, because it never sends password over the wire. So that's in Kerberos. Starting Apache Knox, you get another choice for authentication. And on this slide, you'll see some of the benefits of Apache Knox. And let's talk about some of these benefits and why they're important. So if you have a Hadoop cluster, the question is, in what scenarios will you use Apache Knox? So Apache Knox is the API gateway for REST API. What it means is that if you are using REST as a protocol to access Hadoop, then you have a choice of using Apache Knox. If you're not using REST, and it could be that you're using Hive CLI or HDFS client libraries, those libraries speak RPC protocol. They are not speaking REST protocol. So in that case, Knox is of no help to you. But if your clients are accessing a given Hadoop component or Hadoop services over HTTP or REST, then Apache Knox can help you. So let's talk about the REST scenario a little more. If you had a bunch of components in your Hadoop cluster, let's say name node and data node, and you needed to know if you're accessing the cluster over REST, you would need to know the URL for each node or each component that you're trying to access. So you would leak the network topology to your end users. With Apache Knox, everything goes through a Knox gateway, and that's the single choke point. And it does URL rewriting, so it hides the internal network topology. And it becomes a single access point for your entire data cluster. At that single choke point, it also implements authentication, authorization, audit, and encryption. And it integrates with other existing identity management standards. So for example, Apache Knox will integrate, or it already integrates today, with LDAP and Active Directory as a store of user credentials. It also does SSO integration with SiteMinder, and in future, we plan to integrate with other open emerging authentication standards such as API key-based authentication and OAuth. So let's talk about what are your choices for authorization and audit today. So authorization, as we saw in the previous security rings of defense slide, authorization is specific to each component. So if you wanted to control authorization in Hive, you have the choices of today using storage-based authorization, or when the next version of HDP 2.1 comes out, or the next version of, it's already there in the latest Apache Hadoop if you download. It already has what's called the Hive authorization next generation, which grants the SQL-style semantic to Hive. Similarly, for audit, all HDFS and MapReduce access are audited, and it goes into different audit logs. What is missing today is that there is no sort of like a log loader that sucks in audit log from every Hadoop component. There is no UI on top of it. There is no search capability on top of it. And those are some of the things that are missing. And you'll see when we talk about what's coming in security that we want to address those issues. And hopefully, with your help, maybe we can get there sooner. So for access control, as I mentioned, each component has its own authorization model. So HDFS had file permissions, Yarn, MapReduce, and HBase has access control list. And some of these improvements in the next version of these components are being led by Hortonworks team. So for example, the HDFS extended ACL was implemented by Chris Nuroth, who's here. You can go talk to him about more details about what this improvement is. And if you go to, I'll send some of at the end of the slide, I'll show you some links where you can get more details on each of these projects. Hive authorization improvement is led also by Hortonworks with the project called Hive Authorization Next Generation. So let's talk about data protection and what you can do with data protection. So data protection, as recall that data protection is about encryption. So encryption happens in two phases. One is as the data is flowing through the wire or as the data is being transported. So now this encryption is called encryption encryption in motion or data in motion or wire encryption. So the other encryption is applied when data is resting in the file system or when the data is in the file system, and that is called encryption at rest or rest encryption. So this rest is not the same as the other REST protocol. So encryption of data at rest and in motion. So when the data is flowing, as we know that there are so many different components in Hadoop, and there are many protocols involved as well. So for example, there is RPC, and RPC is the protocol that is used if you're using any CLI or command line interface of Hadoop. For example, if you're using Hive CLI, or if you use HDFS commands, and if you did Hadoop FS LS, under the cover, it's speaking RPC protocol, and RPC protocol is a binary protocol to talk to the name node and to the data node. So for RPC, encryption is done through what's called SASL. So Java has the SASL library for a while, and it's an abstraction rather. And SASL has the encryption capability as well. So Hadoop RPC leverages that. So encryption over RPC protocol is implemented through SASL, what's called SASL quality of protection. So there is a setting, you can enable that, to indicate that you want to have SASL-based encryption. And then the next setting you can specify as to what encryption algorithm you're using. So the default is RC4. The next one is triple DES, which is stronger. So that's encryption in motion for wire encryption. The other protocol where encryption happens is JDBC. So if you're accessing Hive, and you're accessing Hive over JDBC, you can encrypt that. The other protocol where you can talk about encryption is HTTP. So for example, if you're using WebHDFS, in this release or in the HTTP 2.1 release, you will also get WebHDFS with over SSL. And that protocol is called Secure WebHDFS. And that's also coming out in 2.1. So I'm not covering every single technology in detail because what I expect is that you'll need to get an overview of what security capabilities are possible. Then for each of these areas, I'll show you some links where you can download tutorials and actually go through each of these things at your own pace, configure them in your environment. So don't be overwhelmed if you see there are so many different channels because there are other resources available that will go down in more detail. So now talk about encryption at rest. So encryption at rest has, I think I just already talked about this slide, so I'll talk about encryption at rest today. So there is no out-of-box solution for encryption at rest, which is encryption in the file system today within Hadoop. But you have choices. So you can use the operating system for encryption capability. For example, the volume level encryption, DMCrypt library. But that encryption doesn't protect, so that encryption happens at the OS level. And what that will protect you against is if your disk on which you had the data node, if that got stolen, the data would be encrypted. So if you had that encryption enabled, somebody who stole your disk will not be able to read it. But it's not going to help when the disk is in the computer and it's being accessed by different users or different application. OS level encryption is not going to help you there. For the scenario, for that case, you need application level encryption. And that's your option 2 or option 3. If you are also interested not just at the volume level, and these choices are not either or, you can have the volume encryption, which protects against disk being stolen scenario. To the next option is encryption you can do with the custom development. So there are code points of the custom codec available. You can write in your own code that says uses the Java encryption APIs to encrypt a byte as is being written in HDFS. And when you're running a MapReduce job, in the MapReduce job, you have to write a custom code to decrypt the data that you encrypted. So that's option 2. The option 3 is if you didn't want to do encryption and decryption with yourself, you can use a certified partner like Voltage or Protegrity, and they have encryption and decryption API, and that's a commercial solution. Now, if you're wondering between option 2 and 3, like what is calling an encryption API to encrypt and decrypt is not a big job. The problem comes with encryption is with key management. Like anyone who has done encryption knows that encrypting something, it's not very difficult. But if you're talking about how to manage keys at scale, that becomes an issue because then you have to worry about key rollovers. What if keys expire? How do you recover from if the key is lost? And all those scenarios you have to account for. And that's why using a certified partner can help you because all those scenarios have been thought through. Or if you have the expertise, you can build the custom encryption yourself. So these are the capabilities that exist today. Let's talk about, so this slide gives you a summary of what we just talked about. So let's talk about what's on the roadmap. So if you go to hortonworks.com, and hortonworks.com has a section called Labs, where all the new material, what different projects are coming, are being put on hortonworks.com/labs. And you don't have to remember the URL. It's there at the end of the demo or the presentation. So there we have a section on security. And this talks about what Hortonworks thinks that the security roadmap is. So phase 1, it's already there in Hadoop today. Phase 2, most of it is already there in the Apache versions of different projects. You'll get that with HTTP 2.1 within the next few weeks. So that's phase 2. It's almost done as well. The next one is phase 3. So phase 2, what we just talked about, Apache Knox, it's coming. The SQL style authorization, it's coming, and all that. So that's phase 2. And phase 3 will get we'll spend time to correlate audit. So for example, as I mentioned, the raw audit information is there today in Hadoop, but there is no custom tooling built on top of it. You'll have to collect the audit logs yourself and then search through it. There is no ability to correlate. For example, a basic use case for correlation is that somebody comes in and they submit a MapReduce job. That job then reads some HDFS files. You can have a separate log of HDFS read, but it's not correlated to what happened. Why was this HDFS file being accessed? It could be maybe the file was accessed in the scope of running a MapReduce job, or maybe the file was accessed in the scope of running a Hive query or UDF or so on. So correlation can give you ability to cross-link the events. So that's audit correlation, and we want to provide some UI with search capability, some built-in reports on top of that, and that's audit correlation. We also want to provide encryption at rest capability in HDFS, HBase, and Hive. And in Apache Knox, we want to implement some more enhancements, make it support HDFS, high availability. And today, Apache Knox does not support the REST API for Falcon or Ambari. We want to support that. And we also want to support token-based authentication. There was a good talk yesterday about token-based authentication. So that's something we are looking at as well, and we'll uptake that. So that's the tomorrow part of security in this talk today. So this is just more details on what's in the roadmap. But I'll skip this slide and talk about Apache Knox a little bit. So I think you may have seen this version of the slide earlier. What is Apache Knox Gateway? So this image was taken from Facebook. Somebody has Hadoop memes going on Facebook, and they come up with crazy pictures like this, and I thought it was funny. So what is Apache Knox Gateway? It's the gateway for REST API access into Hadoop. It's not, it doesn't help if you're just using RPC. It's there for REST API and HTTP security. So today the model is, if you want to give access to your Hadoop cluster, they have to have an edge node where people can SSH into the edge node, and from that edge node, they access Hadoop CLIs. So that, because you want to avoid end users having to install Kerberos. If you want to have a secure cluster, but you don't want to have Kerberos client installed on every end user's machine. So the way forward is, A, get people to access Hadoop through REST. What it means is that with REST, because the API is available on different form factors, you can extend the reach. And also, then you can start putting more security on top of it with the REST, with Apache Knox. So on this slide, this talks about where is Apache Knox deployed. So Apache Knox is deployed somewhere in the DMZ. So you have your name node, data nodes behind a firewall. The red line indicates a firewall. And Apache Knox is deployed where you had deployed the CLIs. On this slide, it gives another view of the Apache Knox architecture and deployment. So Apache Knox is deployed as a cluster of gateway nodes, and it can front multiple Hadoop clusters. So it doesn't replace the RPC access. You can still have RPC access, but the whole point of having RPC access is that it's the way your power users or super users or admin type users access Hadoop cluster. And they might be running some big jobs, or they might be putting data into your Hadoop cluster. But your analysts, your end users, they can access your Hadoop cluster through Apache Knox Gateway. And with Apache Knox, all the Web HDFS, MapReduce, and different services are supported. So this slide goes into the detail of Apache Knox, which is essentially it's a REST client accesses the Apache Knox. Apache Knox has something called a protocol listener, which determines whether the client is coming over HTTP or HTTPS. HTTPS is enabled by default in Apache Knox, so encryption is already happening at rest without doing anything there. And then it has authentication filters, rewrite filters, identity assertion, and finally it sends the call to the Hadoop cluster. So that's more detail. I'll skip that because I want to show you guys a demo. So just to give you a summary of what this demo will do. So you can see in the demo script, what I'll do is I'll create a few directories in HDFS. I will upload a few files into HDFS. Then I'll run a MapReduce job through Apache Knox. So all this is happening through Apache Knox. So if you go back to this slide, so this is the deployment model that we are following. There is a Hadoop cluster, and I'm running it in a sandbox, the HTTP sandbox on my machine, and I have Apache Knox Gateway fronting the Hadoop cluster. So once you put the firewall in there in your environment, no end user should be able to access the Hadoop cluster directly. All the requests, in that case, the firewall will hide the Hadoop cluster. They shouldn't be seeing your Hadoop cluster. That means if they do a ping or anything, it's gone. So you have completely secured it. Then every request is being routed through Apache Knox. So that's the deployment model that we'll show in the demo. So then I'll submit a MapReduce job. Then I'll look at the job result and read the output file. The MapReduce job I'm submitting is a simple word count example. So this is sort of like the hello world type of example, which is how you submit a job, how do you view the job result, and then we'll clean up after ourselves by removing the directories. So let me switch to the demo. So I have in this virtual machine, I'm running the latest version of HTTP Sandbox. You can go to hortonworks.com and download this sandbox, which is just a virtual machine. And there is a tutorial available on Apache Knox, which has the same script that I just showed you, uploading a few files, submitting a MapReduce job. That's available as a tutorial, and the link is at the end of the demo. So you can download this and run it yourself. But let's run it first time through here. So I didn't want to do any recording and take the risk of running a live demo. So I just ran 3 create commands. So I created a few directories. Now I'll upload a couple of files. I uploaded a few files. Then I'll run MapReduce. So notice when this job is run, at the output there is the job number, the highlighted part. So now I need to query for the job status, whether this job is done, whether it's still running, and I'll use this job number as a reference to my query. So here is the job query. So notice it already has a job number. That's from the last time I ran. So I'll copy this, remove the job number, and get this job number. So in this job output, you'll see the status, which is the job is still running. So I'll query it a few times, and because I don't have a lot of memory on my laptop, and I'm running an entire Hadoop cluster, plus the demo, plus the PowerPoint. So it takes a little longer, but eventually the running status will go into successful. Okay, the state is successful. So the next stage is, let's look at the output of MapReduce. So remember, we are running the word count example, and I'm just using a README file as the input to the word count. So I'll clean the status and show you the output. So it counted different, it's the basic word count example. So that's basically an end-to-end flow from an end user's point of view. And I was using curl in a real production environment. There would be an application on top of the REST API we just showed you. So you can imagine an application, a nice GUI. It could be from a mobile device, could be from a Java EE-based application, or some other type of application calling the REST API into Hadoop. And at that REST API, you put Apache Knox gateway, you put the firewall around your Hadoop cluster. So there is no way inside your Hadoop cluster but through Apache Knox gateway. And then at that gateway, you're putting all the authentication, authorization, audit. So it's a way to implement security around your Hadoop cluster. So that's the demo part. And I think I have 3 minutes left. I'll leave that for Q&A. So before we go to the Q&A, what can you do from this point on? A, you can go to the Security Labs website where you have this sort of like there is a blog post I did on security today and tomorrow. So essentially the same, the written version of the talk today. So you can go read that. I put together a lot of actual how to do certain things. For example, if you're wondering how to do group mapping, or how do you configure MapReduce access control list, or how do you enable wire encryption, all the things that I mentioned, the blog posts are all there on the hortonworks.com labs security page. So that's the second link. The tutorial for Apache Knox, essentially where you can download the virtual machine and run the demo that I just did yourself. That's the third link. If you run into any trouble, the fourth link is how you can address that. So you can either go to forums or you can directly email me. And finally, I want to thank you for coming out here. I know security is important to you. And if there are questions, I'll take them.
Currently, many of our business use you to access our cluster. Because among other things, it also quite nice interface for age-based tables. Would Apache Knox work in that situation, or does that use from SQL?
So the question is, if Hue is the way somebody is accessing their Hadoop client or Hadoop's components, will Apache Knox protect that call? So it depends how Hue is accessing the Hadoop cluster. If Hue is accessing the Hadoop cluster over RPC, then no. The answer is Knox cannot help. But if Hue is accessing the Hadoop cluster over WebHDFS or another REST protocol or HTTP, then certainly you can put Knox there. So I think we need a better answer. I'll get back to you with a better answer on that. Any more questions?
sorry, and at a certain moment, the need came up to create virtual organizations which you give a kind of role-based access control. This is discretionary access control and also a little bit based on. Do you see developments in that direction?
So I'll paraphrase your question for audience and for my own benefit to make sure I understood it. You're asking what is sort of like the future of authorization? Is it going towards RBAC and other models? So there are so many acronyms in access control: RBAC, ABAC, MAC, DAC, and all of them are there. So RBAC today is not evenly supported across Hadoop components. So for example, wherever I said ACL, that is not true RBAC. So the plan is we want to have RBAC so before I say we want to have RBAC, in anything, it's like you crawl and walk and run. So we want to have at least one model of authorization everywhere possible. We want to have the next level up is have role-based access control. Beyond that, I want to have attribute-based access control. I came from identity management at Oracle after being there for 10 years. So I know, at the advanced stage, people are in the financial industry are asking for attribute-based access control. So that's where I want to end up. I think we'll have to take a few steps to get there. Another example, when I said there are so many different components and where you can configure authorization, in my mind, that's not good. That's really bad. Ideally, as a security administrator, I want to go to one console, do some management of security, and it applies to every component. I don't want to see whether this component has MapReduce ACL, the other component has something else. So that's where we want to go. And I think you'll see Hadoop as a community evolving there. Yeah. Okay, thank you. Thanks for coming.